After you have solved now for the velocity of the starting point, we now draw the counter. So that should be drawn counterclockwise. The F is 1.178. So this is velocity vector 8 degrees. And then you now look for the visualize now the problem. Where would be your instantaneous axis? Pwede. So you now extend Q to A. You can make use now, actually this is now the instantaneous axis by extending U5C and U2A. But the next one, hindi nga lang accurate. So this is now your instantaneous axis. Using now your compass until you intersect the line Q5C at point C. Then measure off the length of your velocity vector transfer from the arc. And then connect that measurement to your instantaneous axis. From there, you would know now what would be the length of your velocity vector to be drawn perpendicular to your ground Q5C. So this is now your velocity at point C. Perpendicular to the line, connected to the instantaneous axis. What next? You can use also this one as your instantaneous axis. You now connect point B by line to your instantaneous axis. And then from point C, since that is now connected to B along the line, in an arc, and then along that arc, you now measure the length of your velocity vector at point C, transfer that along the arc at the line connected to point B. So now connect that to your instantaneous axis. That connection, you would know now what will be the length of your velocity vector at point B to be drawn perpendicular to the line connected to the instantaneous axis until you bisect now the measurement along the arc. So this is now your velocity vector at point B. Perpendicular to here, perpendicular. Next. There are the two possibilities. It's either use the vertical axis of the slider and then extend now Q7. Then from that point, you now extend and connect point B to this instantaneous axis too. Using that instantaneous axis from point B with an arc, You can also use this one. Okay, we try to use the former instantaneous axis. So from point B, so an arc up to the line connecting point B. And then along that arc, bukas ka na. Bukas ka na. Sayang pa ako mag-arc sa inyo. Along the arc, measure of velocity v, then connect that to your instantaneous axis. That connection, it will now determine the length of your velocity vector at point P to be drawn perpendicular to the line connected to the instantaneous axis. So this is now the velocity vector at point P. Now with slider and the crank at Q70, you can use now solution composition. How? You can start now with point P from extend now DE. And then from the tip of vector P, drop a line. Connecting that drop a line, and then you can designate this as small p. Measure of the small p. Then transfer that along the line at point P. With that measurement, you can designate this as small p. And then draw a line perpendicular to DE. Now that line will now determine the length of your velocity vector at point E to be drawn perpendicular to your ground Q7. So this is now your velocity vector at DE. Okay. How about your slider? Now with the slider, you now extend EF. You now extend EF. And then from the tip of vector T, drop a line, resolving this into a right triangle. And designate this as E1. Measure of E1 along the line, then transfer that and slide there. Okay, note this as small f. From there, you now draw a line perpendicular to the measurement to determine now the length of your velocity vector as slider f, which is now going upward vertically. So this is now your velocity slider. Okay? So this is two methods. If you cannot locate any instantaneous axis that will complement the velocity vector, you resolve that to the solution na ito.